Okay, we need different interfaces to exchange data in our telemedical systems. In this module, we will discuss the most common serial interfaces, which we can use in all our practical implementations. We will also provide some practical examples in MATLAB and Arduino boards. In hardware design, an interface is a shared boundary across two or more separate components of the system. Embedded electronics is all about connecting circuits to create a symbiotic system. In order for individual circuits to swap their information, they must share a common communication protocol. Hundreds of these communication protocols have been invented to achieve data exchange, and in general, each can be separated into one of two main categories: parallel with several electrical connections carrying parts of the data simultaneously, or serial. The data are sent one bit at a time. We will talk about wired protocols in details later, but before we go on, let's say a couple of words about wireless protocols. Bluetooth is a wireless technology standard for exchanging data over short distances from fixed and mobile devices. With them, we can build personal area networks. Invented in 1994, it was originally developed as a wireless alternative to RS-232 data cables. Wi-Fi is a technology for radio wireless local area networking of devices that provides connection to the internet via wireless access point. Such an access point or hotspot has a range of about 20 meters indoors and a greater range outdoors. Hotspot coverage can be as small as a single room with walls which blocks our radio waves, or as large as many square kilometers achieved by using multiple overlapping access points. All this stuff works on a very high speed, providing the main drawback of Wi-Fi interface, a very large power consumption. What is the main difference between serial and parallel interface? So, parallel interface transfer multiply bits at the same time. They usually require data buses, transmitting across 8, 16, or even more wires, so data is transferred in very large blocks. Serial interfaces stream their data one single bit at a time, only one. These interfaces can operate on a line with 1 or 4 wires. Parallel communication certainly has its benefits. It's straightforward and relatively easy to implement. But it requires much more input-output lines that are too slow. You cannot increase the signal frequency for a parallel transmission without a certain limit. All this is because all the signals from the transmitter need to arrive at the receiver side at the same time. This cannot be guaranteed for high frequencies, as you cannot guarantee that the transmit time is equal for all signal limit lines. So even if you transfer less data per cycle with a serial transmission, you can use much higher frequencies, which result in a higher net transfer rate. Serial port communication, which uses serial ports, was once a very popular method of transmitting data. In serial communication, a byte of data is sent and received through a serial port one bit at a time, over a single communication line. If you look on the back side of older computer, maybe you will find a D-shaped male connector with 9 or 25 pins, also known as a communication or COM port. Considered as one of the most basic external connections to a computer, the serial port has been an integral part of most computers for more than 20 years. Although many of the newer systems have done away with the serial port completely, in favor of USB connections, of course, serial ports are still used in applications such as industrial automation systems, scientific instruments, some industrial and consumer products. Serial ports are still used in these areas as they are simple, cheap, and their console functions are very widespread. A serial port requires very little supporting software from the host system, and we can easily communicate with COM port from MATLAB, LabVIEW, and any other workspaces. So, the term serial implies that a serial port serializes data, which means it takes a byte of data and transmits serially each of the 8 bits of a byte one at a time. Before starting transmission of which byte of data, a serial port sends a start bit, which is a single bit with a value of 0. After a byte of data is transmitted, it sets a stop bit to indicate that the byte transmission is complete. So many settings are required for serial connection: speed, number of data bits per character, parity and number of stop bits per character, and others. The number of data bits in each character can be from 5 to 9. 8 data bits are almost universally used in new application, as this size matches the size of 1 byte. Stop bits sent at the end of every character allow to receiving signal hardware to detect the end of a character. Electronic devices usually use only one stop bit. The data parity stop conventional notation specifies the framing of a serial connection. The most common usage on microcontrollers is 8N1. This specifies 8 data bits, no parity, and only one stop bit. We will use this notation for all our future works with Arduino boards. In contrast to a parallel port where all the 8 bits of a byte are transmitted in a parallel all at one time over a cable with 8 wires, serial port needs only one wire to transmit 1 byte. Bidirectional communication allows each device to receive data as well as transmit it, as serial devices use different pins to receive and transmit data. So this makes a serial port suitable for full duplex communication, in which information can travel in both directions at once. It's important to note that those RX and TX labels are with respect to the device itself. So don't forget that the RX from one device should go to the TX of the other and vice versa. The transmitter should be talking to the receiver, not to another transmitter. Don't forget it, then we will make our connection with Arduino board. A virtual serial port is an emulation of a real one. Such port can be created by a software that enables extra serial ports in a system without the need to install additional hardware. Any name can be assigned to a virtual port, and it's possible to create a large number of such ports in one computer. The only limitation is the amount of available resources, such as operating memory and computing power of your personal computer. Virtual COM ports operate the same as real ones, and any application can work with them as if they were real physical ports on our computer. Each pair of virtual serial ports supports all hardware signal lines and allows setting any type of signal line connection. Virtual serial ports emulate all the hardware serial port functionality, including baud rate, data bits, parity bits, stop bits, and all other stuff. Virtual serial ports are common with Bluetooth and are the standard way of receiving data. Virtual serial ports emulation can be useful in case there is a lack of available physical serial ports on our system, or they don't meet the current requirements. We will use our virtual COM ports in practical works with Arduino boards, and I think that's all for these basics of serial communication.